we just started the ionic equilibrium, right? In ionic equilibrium, we were discussing strong acids, right? Weak acids means first electrolytes, non-electrolytes. Electrolytes means which can conduct the electricity, right? Ions, they are forming the ions or dissociation takes place. So electrolytes once again be classified into strong electrolytes, weak electrolytes. In the strong electrolytes, I gave you the acids, strong acids, right? Strong acids. What are the strong acids? 6 acids which I gave you, right? HClO4, H2SO4, HNO3, HI, HBr, HCl. So these 6 which we need to remember. I already told you. So weak acids I told you. What are the weak acids, Nana? Weak acids. So HClO4, HClO3, HClO2, HClO, H2SO3, HNO2, right? HF, right? H2SO5, all organic acids like right, formic acid, acetic acid, right, H2CO3 and benzoic acids, all organic acids we need to remember. Next, strong bases, right? NaOH, KOH, right? RbOH, CSOH. So then calcium hydroxide, right? Francium hydroxide, right? Barium hydroxide. Strong bases. And one more, weak bases. Ammonia and its derivatives. Right? NH3. NH3 plus water, we could say the NH4OH, NH2, right? NH2OH, like that, weak bases. Okay, strong acids, strong bases, weak acids, right? Weak bases. So first we need to know these. I already told you, right? So then afterwards we discussed salts. 4 types of salts which I discussed. What are the salts which I discussed? 4 types of salts. Salt of strong acid plus strong base. What? Like NaCl. Strong acid plus weak base, right? NH4Cl, one of the example. Next, weak acid, strong base, right? CH3, COONE. Anything we can take, the combinations of course, but majorly which we are taking these examples. Weak acid plus weak base, right? CH3, COO, NH4. Like that. So this salts also important. So these things, first basic things which we need to know when we are entering into the chapter. So then afterwards we discussed areneous acids, right? So then Bronsted-Lowry theory according to and Lewis theory. 3 acid-base theories we discussed. According to areneous theory, the compounds which gives the H plus ions are acids in aqueous water. And the compounds which gives the OH minus ions in the water were called as bases. These are the acids, these are bases. According to Bronsted-Lowry theory, the compounds which gives the H plus ions are acids, and which takes the H plus ions are bases. Next, Lewis theory. According to Lewis theory, electron pair donors are Lewis bases, right? Electron pair donor, Lewis bases, and electron pair acceptors, Lewis acids. Lewis acids. So I already told you these things, and conjugate acid base theory is also explained. For example, HSO4 minus, HSO4 minus, if it is conjugate acid and conjugate base, conjugate acid and conjugate base pairs. HSO4 minus, what is the conjugate acid? H2SO4, very good. Right, SO4 2 minus. I told you, right, how to identify the conjugate acid and conjugate base. In acid A is there, right? A means, I told you, add H plus, like OH minus, otherwise directly we'll take H2O. What is its conjugate acid? H3O plus, conjugate base OH minus. So always reactions, one important point which I told the next point, right? And always reactions are moving from strong to weak, but not weak to strong. So write one reaction, forward or backward. So just predict the direction of the reaction. Write that one. Predict the direction of the reaction. Na2CO3 plus H2SO4. Na2SO4 plus H2CO3. So forward reaction takes place or backward reaction? Please let me know. For example, if we can take anything, it is H2SO4 is there, H2CO3. I told you the strong acid and weak acid. This is obviously strong acid. This is weak acid. So means strong to weak takes place, right? Means forward direction takes place but not backward. So means forward direction. Very, very important concept. Always reactions are moving from strong to weak but not weak to strong. So write one more example and let me know. HCOONA plus CH3COOH gives rise to CH3COONA plus HCOOH. Yeah, let me know this. Let me know forward reaction takes place or backward reaction. Inductive effect I explained, right? HCOOH, strong acid, then the CH3COOH. Means what here is, this is weak. When we compare this, this is strong. When we compare this, but not that strong inorganic acids with respect to organic. So means in this case, backward reaction takes place. Backward reaction is favorable. Write it down. Write one more reaction. Cl minus plus H2 gives rise to HCl OH. So very, very important, 5-star one. One of the important reaction in salt hydrolysis also we will get this. Salt hydrolysis. So actually we know neutralization reaction, right? Acid plus base gives rise to salt plus water. For example, I'm just taking HCl plus NaOH gives rise to NaCl plus water, right? Acid, base. Neutralization reaction is this. This is salt plus water. So here is one of the important topic in the equilibrium. So in ionic equilibrium, that is nothing but salt hydrolysis. Salt hydrolysis. Salt hydrolysis means what? This is which reaction? This is neutralization reaction. Right? Neutralization reaction. Opposite of neutralization is nothing but salt hydrolysis. Opposite of neutralization. So means what? NaCl, salt, hydrolysis, H2O, right? HCl plus NaOH. But this reaction is won't take place. This reaction is won't take place. But remaining salts undergoes the hydrolysis. Which salts? For example, I told you, CH3, COO, Na plus H2O. This is a salt of weak acid and strong base. This we can do the hydrolysis. Means what? What we will get? CH3, COOH plus NaOH. But Na plus OH minus, it is COO minus Na plus get cancelled. Means Na plus counterions of strong acids and strong bases won't undergo the hydrolysis. Right. So means it is anionic hydrolysis. CH3COO minus can undergo the what? Hydrolysis. CH3COOH plus OH minus. Means this reaction takes place, but not this. Why? Why? Yes, the same thing. Always reactions are moving from strong to weak, but not weak to strong. So counter ions, here is counter ions of, here also. This is a counter ion of strong acid, right? HCl is a strong acid. Counter ion means what? After losing the H plus, it becomes Cl minus. Cl minus, if undergoing the hydrolysis, what exactly happens, Nana? HCl plus OH. So HCl is which acid? Strong acid. So strong acids, weak to strong acid takes place. Reaction won't takes place. Means what? Which reaction can takes place? Backward direction reaction takes place. Backward direction. Reactions అనేవి స్ట్రాంగ్ నుంచి వీక్ వెళ్తాయి, బట్ నాట్ వీక్ నుంచి స్ట్రాంగ్. Cl మైనస్ H2 వేసినప్పుడు HCl వస్తుంది కదా. ఈ HCl ఏంటన్నా స్ట్రాంగ్ యాసిడ్, అంటే స్ట్రాంగ్ యాసిడ్ అవుతుంది. కానీ మనకేంటి అప్పుడేంటి వీక్ నుంచి స్ట్రాంగ్ అవుతుందా? రియాక్షన్స్ వెళ్ళావు కదా. సో బ్యాక్వర్డ్ రియాక్షన్ అవుతుంది. అంటే ఇక్కడ వన్ ఆఫ్ ద ఇంపార్టెంట్ థింగ్, ఇక్కడ ఒక క్వశ్చన్ వస్తుంది ఇక్కడ. విచ్ ఆఫ్ ద ఫాలోయింగ్ సాల్ట్స్ విల్ నాట్ అండర్గో hydrolysis అంటాడు క్వశ్చన్. రైట్ ద క్వశ్చన్. విచ్ ఆఫ్ ద ఫాలోయింగ్ సాల్ట్స్ will not undergo hydrolysis. So I'll give the list and you need to identify which salts should not undergo the hydrolysis. For example, CH3COOK, CH3COONH4, NH4Cl, NaCl, KCl, RBCl, SCl, Na2SO4, K2SO4. Any salt. So this is one of the important reaction. Which of the following salts will undergo what? Hydrolysis. Which of the following salts will not undergo the hydrolysis? Which salt? Salt of strong acid plus strong base. Salt of strong acid plus strong base will not undergo hydrolysis. Salts of strong acid plus strong base will not undergo. Which one will undergo? Salt of weak acid or strong base, or in the 1 week should be there. Yeah. First one, it will salt hydrolysis. It can undergo the salt hydrolysis. Second one also will undergo the salt hydrolysis. Third one also will undergo the salt hydrolysis. Right. Fourth one, at NaCl, it won't undergo the, because salt of strong acid, strong base. This is also salt of strong acid, strong base. Strong acid, strong base, strong acid, strong base, right? Strong acid, strong base, strong acid, strong base, strong acid, strong base, strong base, right? Na2SO4 also strong acid, strong. So only salts of weak acid and weak bases also undergoes the hydrolysis, but salt of strong acid, strong base will not undergo hydrolysis. What is the reason? Reactions are moving from strong to weak, but not weak to strong. That would be the reason. Got it? Anybody having any doubt? Very, very important question. There is a huge probability to ask the question from this particular area. This is the one area I told you. So this type of questions we should have the one clarity. So then last class I told you properties of water, right? So we'll discuss that properties of water, then pH, so then Ostwald dilution law. So before going to the properties of water, to put the heading Ostwald dilution law. Ostwald dilution. Ostwald dilution. For example, weak acid. Weak acid. If it is undergoes the hydrolysis or dissociation, directly I am writing the dissociation. For example, pH3, COO minus, H plus. Of course, dilution law, we need to add water. So water will take excess. Yes, sir. So weak acid won't undergo 100% dissociation because it's a weak acid, right? We are taking the concentration C dash dash initial. After some time, this degree of dissociation I told you. T minus, T alpha, T alpha, T alpha. Right? This is an acid, right? Equilibrium constant I would like to say Ka. Ka is equals to what? Concentration of CH3COO minus H plus ion concentration by CH3COOH. So if you are applying this at equilibrium, C alpha into C alpha by C into 1 minus alpha. TC get cancelled. C alpha square by 1 minus alpha. So here I am taking the Ka means acid dissociation constant. Write it down. Ka is equal to C alpha square by 1 minus alpha. In the denominator, so we can neglect the 1 is far greater than alpha. So we can denominate in the alpha, we can denominator in the, we can neglect. Ka is equals to C alpha square. Alpha square is equals to Ka by C. Alpha is equals to root Ka by C. Normal ga AB, so we can take anything. So alpha means what? Degree of dissociation, ionization. We could say the degree of ionization, degree of dissociation. It is sometimes for Ka error. They are asking the pH calculations. H plus ion concentration is nothing but what? H plus C alpha. C into alpha means what? Under root Ka by C. H plus ion concentration is equals to, right, under root Ka into C. H plus ion concentration is equals to root Ka into 0. This is very important to solve the numericals. The pH is equals to minus log H plus ion concentration, which I am going to discuss what exactly the pH and all those things. This is for acid. No. For bases also we can take the same thing. For example, same mode, NH4OH. NH4OH, weak base, NH4 plus OH. Okay. Base dissociation constant, we could say the Kb. No. P dash dash initial concentration after T minus C alpha, T alpha, T alpha. Right? So base, right? I'm just directly writing the Kb, base dissociation constant, NH4 plus concentration, OH minus ion concentration by water, NH4 OH. So now T alpha into C alpha by T into 1 minus alpha, Tc get cancelled, Kb is equals to what? C alpha square by 1 minus alpha, 1 is far greater than alpha, we can neglect the in the denominator. Kb is equals to C alpha square is equals to Kb by T, alpha is equals to under root Kb by T. Here is OH minus ion concentration is equals to T alpha, T into alpha value, Kb by T. So OH minus ion concentration is equals to the root Kb, not K, that KBC is Kb into C. So POH is equals to minus log OH minus ion concentration. Right, of course I'll discuss pH plus POH is equals to 14. So these I'll discuss now. Coming cases. For bases also we need to know this. And degrees, right, one more important point, right? Ka and Kb changes with only with temperature. Ka and Kb, this Ka and Kb changes only with temperature. Factors affecting the alpha. Next, factors affecting the alpha. Degree of dissociation or degree of ionization. If alpha is equals to 1 means what? 100% dissociation is takes place. If alpha is less than 1 means, so means this is alpha between 1 to 0, 0 to 1. 0 means reaction, means without any dissociation. 1 means 100% dissociation is takes place. So here is the first point, will nature of factors affecting the alpha and delta. So nature of, it's affecting the nature of solute first. Nature of solute. Nature of solute, it affects nature of solvent, nature of solvent, nature of electrolyte, So it depends on temperature, depends on common ion effect, nature of solute, nature of solvent, nature of electrolyte, temperature and common ion effect. The first one, the nature of solute. So the heading nature of solute. If it is weak electrolyte, solute is weak electrolyte or strong electrolyte, anything we can take. If it is weak, alpha is what? less than 1. If it is strong electrolyte, weak electrolyte another. Alpha is equals to 1. Alpha is equals to 1. So generally in the numericals, if the Ka or Kb or any K value is given, equilibrium constant if they are giving, what we need to understand? So that is weak. Weak cases only they will give the Ka or Kb. For example, strong cases Ka or Kb won't give. Okay, so write that one. Weak cases alpha is less than 1. Less than 1 means what? Ionization or dissociation is very less. Yeah, write it down. For weak acids and weak bases only they will give the Ka and Kb values. For weak acids and weak bases they only give the Ka and Kb values. In case of strong cases, Ka is not needed because 100% dissociation takes place. Next, nature of solvent. Nature of solvent. So solvent nature, solvent its nature is, solvent should be polar in nature. Write it down. Solvent should be polar in nature. Solvent should be polar in nature. And its dielectric constant should be very high. Dielectric constant should be very high. Dielectric constant should be very high. So water satisfy both, Nana. Water satisfy this both polar. Write it down. Water satisfy both polar as well as dielectric constant. Water satisfy the both polar as well as dielectric constant. That's why water we are called as universal solvent. Universal solvent. Nature of electrolyte. Nature of electrolyte. Nature of electrolyte. I already told you, if it is strong electrolyte, alpha is equals to, alpha is equals to 1. Means what? 100% dissociation takes place. 100% dissociation takes place if it is a strong electrolyte. If it is weak electrolyte, on dilution, right? Weak electrolyte, alpha is inversely proportional to C. Means what? Concentration is decreasing, alpha value is increasing. Write it down. Alpha is inversely proportional to C, or C is inversely proportional to alpha, we can say. Means what? Concentration is increases, alpha is decreases. At infinite dilution, each and every one, either strong or weak, both, all are acts as a strong electrolytes. Write it down. At infinite dilution, each and every electrolyte acts as a strong electrolyte. At infinite dilution, each and every one acts as a strong electrolyte. Mean infinite dilution means after adding the lots of water, each and every one acts as a strong electrolyte. Temperature. If the temperature increases, obviously what exactly happens, Nana? If the temperature increases, alpha is increases simply. Speed of ions also increases. So temperature increases, alpha is increases. The temperature increases, degree of ionization. Next, common ion effect. Common ion effect. I explained this common ion effect in the Le Chatelier principle, right? If the common ion is there, what exactly happens? The alpha value. Because of common ion effect, common ion effect increases, alpha value is decreases. How? How? For example, try to understand. CH3COOH is present in a CH3COO minus H plus. Is present in a container. Imagine. Okay. Now I'm adding some small amounts of HCl. HCl is a strong acid, right? 100% dissociation takes place. So H plus coming and is undergoing H plus plus Cl minus. Right? Now one common ion is coming here. What is that common ion? H plus. So product side concentration, what exactly happens? Increases. H plus concentration is increased. H plus ion concentration. What exactly happens? Backward reaction takes place. It is suppressed. Actually, this is a weak acid. If you are mixing with a strong one, so this degree of dissociation or ionization will be suppressed or dramatically decreased. Okay. So this is called common ion effect. Because of common ion effect, according to Le Chatelier principle. What I told in the Le Chatelier principle, if the concentration of reactants increases, reaction moves opposite direction, right? For example, this example which I gave you in the preparation of ammonia, N2 plus 3H2 gives rise to 2NH3. Yes or no? In the Le Chatelier principle, if you are increasing the concentration of nitrogen and hydrogen, right? Concentration, what exactly happens, no? It moves the forward direction. Yes or no? So the same mode, if you are increasing the concentration of ammonia, backward reaction takes place. Exactly here is because of common ion effect. Common ion effect, what exactly happens? Backward reaction takes place, means alpha is decreasing. Alpha is decreasing. Degree of dissociation takes place. This is very, very, very important to calculating the pH calculations, the common ion effect, which we will discuss there also. For example, in the problem, for example, CH3COOH is given, HCl is given, right? When along with CH3COOH and HCl, try to understand, CH3COOH and HCl, when we are mixing these two, because of common ion effect, actually CH3COOH by default it's a weak acid. By default it's a weak acid, right? When we are adding the strong acid, what exactly happens? Its dissociation is further decreased. This is because of common ion effect. Why common ion effect? Because HCl is a strong acid, 100% dissociation takes place. In the product side, H plus concentration increases. Because of increasing the H plus ion concentration, reactions are moving towards the backward direction, right? And its degree of dissociation will be decreased. So water, nothing but water. It's a pure water, neither acidic or basic. It's neutral. It acts as an acid and it acts as a base, depends on the condition. The last example which I told you, right? If it is in presence of NaOH, it acts as a acid. In presence of HCl, it acts as a base. So water is a universal solvent. Write it down. So H2O, properties of water, H2O gives rise to H plus plus OH minus. H2O will becomes H plus plus OH minus. Water is neutral, neither acidic nor basic. So molarity of water, Nana. So this is very important. Sometimes molarity of pure water we need to calculate. They didn't give anything. So the value which we need to remember. 55.5. So molarity means what? Number of moles by volume of solution in liters. For density of water, 1 gram per cc. Per gram per ml we can say. So molar mass 18 grams. Right? Volume is 1 liter. Right? So write it down, this density, molar mass and volume. 1 liter solution, nothing but 1000 grams of water. By its molecular weight is 18 into 1 by 1 liter. We'll get 55.5 molarity of pure water. So this value they won't give, so we need to calculate and we need to remember, because we'll consider the density of water is 1 gram per ml. So molarity is equal to 1000 by 18 into 1. So I already gave you 55.5 mole per liter. 55, 55. So we need to remember that. Once again I am telling, molarity is equals to, right, weight by molecular weight, number of moles into 1 by V in liters. For 1 liter, right, we are discussing. So 1 liter gram, 1 liter nothing but how many ml? 1000 ml. Density is equals to 1 gram per ml. Weight means what? Density is equals to mass upon volume. Mass is equals to density into volume. Density is 1. Volume is 1000 ml. Is nothing but 1000 grams. We'll consider 1000 grams. Its molecular weight. So 1000 by molecular weight 18 into 1 by 1. Nothing but 55.5. Don't confuse. Next, ionization constant of water. So H2O, H plus plus OH minus K equilibrium H plus products concentration by reactants concentration. So because H2O is almost all negligible, so K equilibrium H plus plus OH nothing but KW, ionic product of water. KW is equals to K equilibrium constant. So KW is equals to H plus into OH minus ion constant. At 25 degrees centigrade, right, experimental data, this is 10 to the power of minus 14 KW value. At 25, particularly at 25 degrees centigrade only, 10 to the power of minus 14. So H plus ion concentration is equals to OH minus ion concentration is equals to 10 to the power of minus 7. Ionization constant of water, and the remaining year onwards I'll discuss tomorrow. Tomorrow I'll discuss pH calculations. pH of different acids, mixture of acids, weak acid, strong acid, weak base, strong base, mixture of strong acid, weak acid,